Hello everyone, welcome back. Today we'll be going over a new technique known as integration by parts. And this is usually performed when we have two functions right next to each other being multiplied. And as you can see, u substitution really wouldn't work. If we try setting u equal to e to the x or x, nothing would cancel out. And things wouldn't be nice and simple like they have been in the past. So we have to adhere to new techniques. And this integration by parts technique has a formula which goes a little something like this. Here, there it is. The formula is the integral of u dv equals uv minus the integral of v du. And this looks like a mess. So there's another way we can write it, and I personally like to write it like this: f g prime equals fg minus the integral of f prime g. And the reason I say this is a lot more simple is because sometimes you will have to use u substitution within the integration by parts, and if you have variables like u and dv floating around, it can make things really complicated. So I just like to see this as two functions. You have f and g, or f and g prime at the very beginning before you solve, and all you have to do is determine which one's your f, and the other one will obviously be g prime. So, but in order to do this, we have this thing called LIATE. And although some of you may have heard this, LIATE is basically just a technique or a little acronym that stands for logarithmic functions, inverse trig functions, algebraic functions, trigonometric functions, and exponential functions. And this basically helps us to determine our f function. Because once we know f, the other one's going to be g prime, and then we could just plug it into this formula right here. So in order to do this, we have to look at what we started with. And we have x, and x falls under algebraic. And algebraic, here, let me do it again. Algebraic is just basically any polynomial, any powers of x, like x squared, x cubed, x cubed plus 2x, anything out of the sort, anything that's not, logarithmic, inverse, trigonometric, and exponential. And then we have e to the x, which is just exponential. And the one that came first was our algebraic function. So because this one came first, that means that has to be our f. And we'll approach this the same way every single time. And before we get started, I always like to make a little chart on the side before I get ahead of myself. So I write down f, and then f prime, g prime, and then g. And then I find all of these. And we're already given two of them. So since algebraic came first, that means f is x. And the derivative of x is just 1. And then g prime is e to the x. And then it's the same thing. If we take the integral to find g, it will just be e to the x. Now we have everything we need to plug into the equation. So this is just kind of like our guide. So now we could plug everything into the equation. So this part right here is what we're given with, what we're started with. And the real formula comes in right here. So we know that f is going to be x. And then g is right here, which is going to be e to the x. And then minus the integral of f prime, which f prime is just 1. And then g, which is just e to the x dx. And now our main focus will be this integral right here. So we bring everything down and we continue solving. Integral of e to the x dx. So we have x e to the x minus e to the x plus c. Can't forget your plus c because it's in an indefinite integral with no bounds. And you know, although we could stop here, I'm just going to continue to factor this out just to make it look a little cleaner. So we're going to have e to the x x minus 1 plus c. And that is our final answer.